Good morning to all. In my previous video session, I already discussed about the CNC EDM and how they are to operate with the EDM and what is the difference between conventional and unconventional machining process. Today I am going to discuss about the new topic related to the CMM. First of all, what is meant by CMM means coordinate measuring machine. It is one of the metrological equipments to measure the dimensions of the given objects. This is the general introduction for an CMM. We are having the generally n number of CMM types are there. Based on the working condition and necessity of the calibrations, we have to select any kind of CMM, coordinate measuring machine. First of all, what is meant by CMM means coordinate measuring machines are extremely powerful metrological instruments. We are already having a number of metrological equipments like vernier caliper and screw gauge. So a number of different conventional type of calibration tools are there. When compared to that kind of conventional machining tools, it is a powerful techniques to measure the outer dimensions of the any kind of objects. Okay. Then second, it is the device for measuring physical geometrical characteristics of an object, which is denoted as, for example, we have to take this is the rectangular object. So first we have to fix the reference point. Based on the reference point, we have to measure the outer dimensions of this object by using this kind of CMM. Okay, not only for the rectangular object, any kind of complex object also we have to choose, and we have to measure the outer dimensions by using this kind of CMM. These machines may be manually controlled by an operator, or it may be computer controlled. Because in olden days these CMMs are operated by using the human beings, so it may be the human beings are manually operated this kind of CMM for the calibration techniques, or otherwise we have to use the CNC, computer numerical type, which will be used to control the entire CMM process. Okay. Then next one is for measurements are defined by the prop attached to the third moving axis of this machine. Because in our CMM we are having the three axes. So both two axes we are having the column. It will be fixed, either it may be a cantilever type, or it may be a simply supported type, or fixed type. Okay. So remaining two axes will be an x1, y will be an column type, and in our third axis we have to fix the prop. Prop may be fixed either horizontal or vertical direction. It is highly sensitive to measure the outer dimensions of our object. Okay. The prop touches the part of interest and allows the collecting discrete points of this object surface, which means first the prop will be touches the part of reference point. It will be move along the horizontal and vertical directions. After that again it will be reached the again and again to the reference point. Based on the reference point, it will measure the, for example, what length in that axis and what length in that axis, and also measure the thickness of the object also. Okay, not only for the rectangular object, some of the circular component and irregular geometry also measured by using this kind of CMM methods. Okay. So these are all the roles of coordinate measuring machines. CMM plays an important role in the larger number of industries, including these are all the different applications of CMM. Wherever the industries, they have to refer the CMM for the quality inspection control. Okay. First one is for aerospace, second one is for automotive, and third one is food processing, healthcare, paper, then paranutrical, plastics, research and development, R&D sections also. CMMs are plays a major role, and semiconductor. These are all the different industries. They have to prefer the CMM for the calibration tool. Okay. Then next, CMMs are the particularly suited for the following conditions. These conditions may be preferred for the selections of CMM for the calibrations, like shorter runs and multiple features, flexibility, high unit cost, and production interruption. Shorter runs means in short durations and short runs we have to easily calibrate the outer dimensions of our object. And multiple features means not only measure the in single object we are having the circle, and we are having the internal thread, and we are having the length, thickness and breadth. So a number of features are there. So multiple features means by using this kind of CMM we have to calibrate all three dimensions of this all the features. That's why we are mentioned as the multiple features. Then next, flexibility. Flexibility of machining operations will be high when compared to the conventional machining process, and high unit cost, production interruption. Because why? What is mean by production interruption means once the quality is failure means automatically the component will be rejected, so the production will be automatically reduced. Our ultimate aim is to increase the production rate and MRR. That's why here mentioned as the production interruption. Production will be based on our quality control. Okay, so this is the general comparison between the conventional and the coordinate measuring technology. Conventional means our humans are using some other tools to measure the calibration, and in our CMM means computer which is used to measure the outer dimensions or inner dimensions of our projects. This is the general comparisons. Like manual means time consumption will be high, here the time consumption will be less, and this is single purpose only. For example, length only measured means length only we have to measure. Here we have to measure all the multiple features like length, breadth and thickness. And next, the comparison of measurement with the materials measures. Different types of materials we have to measure by using both kind of conventional and CMM methods. And separate determination of size, form, location and orientation with different machines. So different machineries having the different location for the manual kind of operation. So it is difficult for setting of human beings. But here different kind of machines, they have to set the different kind of axis for own settings by using the computer technologies. Okay, this is the general comparison for this kind of tool. So in our next session, we have to discuss about the different types of CMM and how they are calibrated by using the different specification and all. Okay, thank you.